Welcome to our guide on handling exceptions in Java. In this video, we'll cover the essentials of managing errors effectively in your code. We'll start with the try-catch block, which allows you to catch and handle exceptions gracefully without crashing your program. Next, we'll get the finally block, which ensures that crucial cleanup code runs regardless of whether an exception occurs. We'll also explore how to throw exceptions deliberately when your code encounters an error condition, and how the throws clause is used to declare exceptions that a method might throw. Finally, we'll dive into creating custom exceptions, giving you the power to define your own error types for more precise error handling. Ready to master exception handling and make your code more robust? Let's dive in. The try-catch block is essential in Java for managing exceptions, allowing developers to encapsulate code that might throw exceptions within a try block, while defining specific responses in one or more catch blocks. This structure enables handling different exception types distinctly, as you can include multiple catch blocks for various exceptions, such as IO exception and file not found exception, each tailored to the specific error. This approach not only helps maintain the robustness of your application by allowing it to respond gracefully to errors, but also enhances code clarity. A practical exercise could involve implementing file handling operations where you utilize multiple catch blocks to effectively manage potential exceptions, reinforcing your understanding of effective error handling. The finally block in Java is essential for ensuring that specific cleanup code runs regardless of whether an exception is thrown in the preceding try block. This block is typically used to release resources, such as closing files or database connections, ensuring that these actions are taken even if an error occurs. For example, when reading from a file, you might structure your code like this: after attempting to read in the try block, you handle any potential exceptions in the catch block, and then use the finally block to close the file. This guarantees that the file will always be closed, preventing resource leaks and maintaining application stability, thereby enhancing the reliability of your code. The finally block in Java is essential for ensuring that specific cleanup code runs regardless of whether an exception is thrown in the preceding try block. This block is typically used to release resources, such as closing files or database connections, ensuring that these actions are taken even if an error occurs. For example, when reading from a file, you might structure your code like this: after attempting to read in the try block, you handle any potential exceptions in the catch block, and then use the finally block to close the file. This guarantees that the file will always be closed, preventing resource leaks and maintaining application stability, thereby enhancing the reliability of your code. The throws clause in Java is a crucial part of method signatures, signaling to the caller that the method may throw certain exceptions that need to be handled. This is especially important when dealing with operations that can fail, such as reading from a file or connecting to a database. For example, if you have a method that opens a file, you might declare it as public void open file throws IO exception, indicating that the caller must be prepared to handle an IO exception. This not only promotes better error handling practices but also makes the code more readable by clearly communicating potential issues that could arise during execution. Custom exceptions in Java are user-defined classes that extend the exception class or its subclasses, allowing developers to create specific error handling that aligns with the unique requirements of their applications. By defining custom exceptions, you can provide clearer context for errors, making it easier to understand and manage exceptions in your code. For instance, if you need to validate user age, you might create an invalid age exception that throws an error when the age input falls outside acceptable limits. This not only enhances the clarity of your error messages but also allows for more granular control over exception handling in your application, making it easier to maintain and debug. As we conclude our exploration of handling exceptions, we've equipped ourselves with essential tools for managing errors and ensuring our programs run smoothly. We started with the try-catch block, which provides a mechanism to catch and handle exceptions, preventing them from crashing your application. We then discussed the finally block, which ensures that critical code executes regardless of whether an exception was thrown. We explored how to throw exceptions manually to signal error conditions, and the throws clause, which allows methods to declare that they might throw certain exceptions. Finally, we looked at custom exceptions, empowering you to define your own exception types for more specific error handling. With these techniques in your toolkit, you're well prepared to create robust and resilient applications that handle errors gracefully. Embrace these practices to enhance your code's reliability and user experience. Happy coding, and may your exception handling be both effective and elegant.